So the topic for this particular video will be interface segregation principle, or more commonly known as ISP. This represents the I in solid principles that we are currently covering up. First of all, hey, what is the definition of ISP? Let's understand that. The definition is very straightforward. Clients should not be forced to depend on interfaces that do not use. In much simpler terms, it means do not create large and bloated interfaces, like an interface which has a lot of behaviors. That means any class that is implementing that interface has to implement all of those behaviors, and that is something we shouldn't be doing, because imagine a class doesn't want to implement everything, then that's an issue. That is why you should avoid creating large and bloated interfaces. It should be as sleek as possible. It should have as minimal stuff as possible. Break them into smaller and more specific ones. Instead of creating one interface with all of the functionalities, you should be breaking it down into multiple interfaces and have small functionalities integrated into them. What do I mean by that? Imagine you have an interface X and you have multiple functions inside it, and any class A that is implementing the interface X now has to implement all of the functionalities. That might not be necessary, because what I'm doing is I'm forcing the client, which is the class over here, to implement all of the things under the interface, and there might be things which he doesn't need. So thereby I need to make sure the interfaces are as sleek as possible, as minimal stuff is there. That is what we should be preferring it. And the principle states you should be breaking them down to smaller and more specific ones. Instead of having a single one, break it down into multiple. So that is the definition of interface segregation principle. I hope you understand that. So now that we know about the definition of ISP, it's time to understand ISP through an example. I'll take the example of Uber. Now, when I talk about Uber, primarily we have two high-level components that drive Uber. The first one is the rider, who's going to book the ride, who's going to pay for the ride. The next one is the driver with the cab, who's going to take the rider and have the ride and other stuff. So primarily on a higher level, we have majorly two components. So I'll be taking these two components and I will try to explain you ISP. Okay, perfect. So imagine I go ahead and say interface Uber, and I'll say void book ride, because that's the first step. I'll say void accept ride, because that is the second step. I'll say void drive car or drive vehicle, whatever you want to do, void drive. I'll say void end ride, and I'll say void pay for the ride. Typically on a very high level, these are the functionalities that will be covering up Uber, correct? Now, this is where we are violating ISP. Now, under a single interface, we have so many things. We have bloated the interface with just too many things. Now, I have a class which is for the rider. Now, the rider is going to implement Uber. I'll have to implement everything, like a book ride, like an accept ride, like a drive, like an end ride. Now, these three functionalities should not be implemented by the rider. So if you now go back to the definition is stating clients should not be forced, because the rider is implementing Uber, he'll be forced to implement accept ride, drive, and end ride. And that should not be the case. And that is the definition of ISP. ISP is stating break them into smaller and more specific use cases. So what I could do is, because I know that this is an interface which is a bloated interface and it's violating ISP, I'll go and say rider interface, and I'll just take these three out, and I'll make one more interface. I'll break it down into smaller, and I'll say driver interface, and inside the driver interface I'll put them in. And now over here I can say public void book ride, and you can implement it. And at the same time I can say public void pay for the ride, because he'll have to pay for the ride as well. And I could simply give rider interface to it, And at the next step, we're done. If you see, the rider doesn't need to implement unnecessary stuff. Why? Because I've broken down the interfaces into smaller ones and more specific ones. And this is what ISP states. Similarly, if I have to implement the driver class, I can also implement the driver class with the driver interface. And I could simply say public void accept ride. Obviously, there will be logic inside it. I'm not writing the logic as of now. And similarly, you'll have a drive. And similarly, you will have an end ride. So now we have two different clients. One client is rider, the other client is drive, and we are not forcing anyone to implement any of the functionalities that they do not offer. And this is where I have successfully implemented ISP on a very, very smaller scale. Again, this could be scaled to multiple bigger examples, but because I'm explaining you ISP, I'll try to keep it as short as possible. I'll get back to the iPad, and now I can say that, okay, we now understand ISP through the definition and through the example as well. Now, what are the benefits of ISP? I think you know that, but still, let's go through it again. We offer modularity, which means the code becomes much more modular, and we also offer flexibility. Tomorrow, we want to add one more interface, we can do it. And if the rider wants to implement it, we can have it. If the driver wants to implement it, we can have the driver implement it as well. Now, because it is flexible, I'm not adding it to the existing interface, because adding it to the existing interface will mean everyone that is implementing that interface has to implement it. So that is why it's better to segregate interfaces into smaller parts so that we are flexible enough to change code going in the future. Improves testability. Now, because the interface has limited functionalities, for a single interface, it will be easier for me to write unit test and to test it. If the interface has multiple functions and it is bloated, now writing unit tests might be a nightmare because I'll have to test so many functions inside it. And eventually, if something changes or something breaks, it's going to be even tougher for me to understand, okay, where is the issue? So, improves testability. Prevents accidental implementation of irrelevant methods. Now, it won't happen, but just imagine if the rider in the Uber class is driving the car. Does it make sense? No, because the driver has to drive the car. As a rider, I can't drive the car, specifically a car that belongs to the driver, right? So accidentally, it might happen you implement that functionality and someone would accidentally end up using it. So that is why it's better to segregate them into smaller interfaces and make sure they're aligned to the clients that need it actually. Perfect. Makes the code easier to understand. Smaller pieces of code, much easier to understand. Bloated piece of code, again, very difficult to understand. That goes without saying. So we know about the benefits of ISP now as well. Next one. When do we apply ISP? Let's understand that as well. 2 points. Whenever your interface is doing too many things, if you feel that this particular interface is doing too many things, try to break it down into multiple interfaces, and then you can have the client implement multiple interfaces. What do I mean by that? Imagine you had a X interface, and that is getting bigger and bigger. What you could do is you can break it to X and Y, so you can have two interfaces with them having functionalities divided between them. Now, if you had a class A which was just implementing X, you can have it implement Y as well. So that is how you can break it down into smaller pieces and it becomes readable as well. Perfect. When some classes implementing an interface throws error, as I said in the Uber example, if the rider is going to drive a car, if the rider is going to accept a ride, there's an issue, isn't it? So that is where you'll have to understand if any of your client, while implementing any of the interfaces, is throwing an error that, hey, we don't want this, we don't want to implement this, this is not our functionality. That's when you understand maybe a portion of that code can fall under ISP and I can segregate that into a new interface. That's where you'll have to think. Understood? Perfect. So that is when you will be applying ISP. That's it. So that was it for ISP, which is the I in solid principles. And yeah, that will wait for this one. Thank you so much for watching. Let's meet in the next one, where we will be covering up the D in solid principles.